So we see x squared plus 4, so our trig sub is going to be tangent. So it's going to be 2 tangent x, because the square root of 4 is 2. Never forget to get your dx. It's going to be 2 secant squared x dx. Then I like to come to the side and simplify this x squared plus 4. This is going to be, x squared is going to be 4 tangent squared x plus a 4. So if I pull out a 4, that's 4 times tangent squared x plus 1, which is the square root of 4 times the secant square root of x, which comes out of the square root just like we planned. So that's a lovely 2 secant x, no more square root for us. So when I rewrite everything, this is 1 over x is 2 tangent x, so this is 4 tan squared x. This square rooty part ended up being 2 secant x, and then the dx is 2 secant squared x dx. So everything has been substituted. Now we just clean this up. The 2's will cancel. One of the secants will cancel. So on the top you have secant x dx, and on the bottom, yuck, you have a 4 tangent square root x. And just another, no, the secant cancels. So now you're left with just all these trig functions, so maybe your trick is to rewrite everything with sines and cosines and hope things cancel. I'm going to pull the 1/4 out to the front, and secant is 1 over cosine, and tangents is sine over cosine, so since it's on the bottom, this is going to be cosine squared over sine squared dx. So one of the cosines will cancel out, and then you'll just get cosine of x over sine of x. This is much, much better, because now I can do just a little u sub. If I let u be the sine, then du is the cosine of x dx, which is sitting on the top. So this is 1/4 the integral of 1 over u du. So it's 1/4 the ln of the absolute value of u, which is sine. And some people may have just memorized, this is cosine over sine is cotangent, so some people have that memorized as the ln of the absolute value of sine, but if you didn't, the u sub works. So we're here. Oops, shoot. All of these x's are supposed to be thetas. X can't equal 2 tangent x, that's silly. Thetas everywhere you see an x, right? Theta, 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 theta. Thetas. Right? My bad. Alright. Because I was like, at the end, I'm like, oh, look, we've got x, which is what we wanted, but no, we have ln of the sine of theta, and we don't want thetas, we want x's. So now you got to go back all the way to your original trig sub and make a triangle. So if you go all the way back to your original trig sub, make a triangle. If x equals 2 tangent theta, just divide by 2. That means the tangent of theta is x over 2. So I'm going to draw a triangle whose angle has a tangent of x over 2. With Pythagorean theorem, it's going to be the square root of x squared plus 4, which is, no quinky-dink, the same as the original. And now I can pull whatever trig function I want off of there. I happen to want sine. So this is going to be 1/4 the ln of the absolute value of x over square root of x squared plus 4, since sine is the opposite of the hypotenuse. Add a c, and that's it.